Welcome back to Project Pulse. In the previous lesson, we finalized our term loan structure, meaning we now have the full debt service profile per period, interest plus principal. And once we have that, we can calculate one of the most important lender metrics in the entire model, the debt service coverage ratio, or DSCR. In the top right corner of our model dashboard, you can see the DSCR chart. The dark blue bars are the actual DSCR for each year, and the red dashed line is our lockup DSCR threshold. In the current live case, case 8, we are mixing contracted and merchant revenues, so cash flows fluctuate over time. That's why the DSCR profile is not perfectly flat. Now let's switch the live case to case 1, the full tolling case, which is a fully contracted case. Watch what happens. The DSCR becomes flat and you will see it sitting right at the contracted sizing DSCR, which is 1.3. And that's what we would expect, because when the lender sizes and sculpts step to a target DSCR, a stable contracted cash flow profile will typically produce a stable DSCR result. If you're new to this Deal Lab series, I recommend starting with part 1, where you can download the model start file for free and build the model alongside me. Link is in the video description below. Now let's move back to the model checkpoint file from our previous lesson. And in this lesson we will focus on implementing our debt service coverage ratio right in this section. And just a quick reminder, the debt service coverage ratio measures how many times CFEDS covers total debt service in a given period. So it's the lender's core safety check. Do we have enough cash this period to pay interest and repay principal with a buffer? And that buffer is essentially reflected in the DSCR. Anything greater than 1.0 is the buffer to the lender. And the DSCR directly drives credit comfort, covenants, and also lockup restrictions. So the first key input we need to calculate our DSCR are our CFEDs, and our CFEDs are further up in the section, right at the beginning of our senior debt, and that is row 487. Which reflects our CFEDs after considering levered taxes. So select K487, drag this one over, Control R, and then it's going to be a simple linkage of further outputs we have calculated in previous lessons. So that is also the term loan interest, which is part of our total debt service. So let's search for our term loan interest. And that is actually right up here. And what we want to make sure for the actual DSCR output is that we link it to our interest including base rate sensitivity. So when we see our DSCR on our output sheet later and we run a sensitivity, that it already reflects any interest rate hikes that we might assume. So link it to 573, hit enter. Then next up is our debt service reserve LC interest, which we have not yet modeled, but we do the linkage anyway. So let's scroll down to our DSR LC section. And the total interest paid is actually the very last row of our senior debt in 664, which is going to be our hard-coded paste line. So let's just introduce that linkage for now, although it's 0, hit enter. And then one of the most important and significant debt service positions is going to be our principal. So let's pull in our principal. And the principal repayment we can take straight from our term loan account in row 555. And now watch out, the principal repayment here is actually negative. And the interest expenses we'll pull in for the debt service are positive. So let's flip the sign. That is minus 555. Hit enter. And then the last part of our total debt service might be our cash sweep, which we will implement in the next lesson. But for now, let's just highlight this row so we don't forget to implement it later. And that allows us to take the total sum of these 4 items, which are our 2 interest expenses, term loan principal, and any cash sweep that may apply. Hit enter. Let's drag all of this over, Control R. Let's actually hit Control Z and just copy this and paste special formats. So mark all of this Alt HVSF, so we keep our formatting. And you can see that our DSCR formulas have already been implemented. So there's no need of further implementing those formulas, but let's just check what happens down here. And we will actually calculate two different DSCR outputs, one excluding our cash sweep for info purposes only. So what we take here is our two interest expenses plus term loan principal, excluding any cash sweep. So the formula is fairly simple. We just take our CFETs in that period and divide them by our debt service due. And that results in a DSCR of 1.53 in the first period. And the DSCR including any sweep is the same output, because for now the sweep is 0. But once we model our cash sweep in the next section, you will see that this DSCR, once the sweep kicks in, must be 1.0. Then we also have a lockup DSCR. The lockup DSCR is an input. So once this lockup here is breached, meaning the DSCR falls below 115, then we won't distribute any dividends to the equity investor, but instead start building up cash for any potential cash shortfalls to the lender. And this formula basically says that we only want the lockup DSCR to show up if this DSCR here is active, and our DSCR is only going to show up if there are any values, otherwise we won't see the outputs. And this has been incorporated that way in the model because it simplifies building the charts later. Which means the only line item that's missing for this lesson is our lockup. And this is a simple check to see whether we are in lockup or not. So we want an if statement for this one, and we need two conditions to be fulfilled. So let's do an if and statement. And here we will look at our DSCR including our sweep. So if this DSCR is different from no input given, meaning we only look at the lockup if there's actually a DSCR reflected in 587, so just type quotation marks, then comma, the second condition is that our DSCR including sweep, so 587 again, is smaller or equal to our lockup DSCR, and we can actually pick up the input cell right here and fully anchor this one, hit F4, because the lockup requirement doesn't change over time, so we can just pick up that source right here. We are only representing it as a time series for our chart purposes. Close parentheses, so if these two conditions are fulfilled, then we want a 1, meaning we are in lockup, otherwise a 0, close parentheses, hit enter, and let's drag this one over, Control R. So right now we are not in lockup, but let's see what happens if, say, we have a sweep of an additional 8 million in the last period. You can see in that case our DSCR would actually be at 0.69, which means we would trigger a lockup, and the 0.69 would actually not even allow any cash flows to equity. But if the DSCR would be between 1.0 and 1.15, we would not allow the equity sponsor to distribute any profits in that given period. So let's delete this cash sweep value for now that we know that our lockup flag works properly. You will also notice that we are calculating the average DSCR over the full financing tenor right here, as well as the minimum DSCR. So here we just take the minimum. That's also the reason why our formula is only showing up if there are actually inputs, because if there would be a 0 right here, our min formula wouldn't work. So hit Control Z. That's the reason why we set up the formula with the quotation marks right here. And then we don't only just know our minimum DSCR, we also determine with an X lookup when this minimum DSCR occurs, during which date, and we will know that it's on the 31st of December 2037, right here. Now you will notice that there is a light fluctuation in the DSCR, because in case 9 we actually have a mix of contracted and merchant cash flows. So let's see what happens if we do our full tolling case again. And now be careful before we interpret these DSCRs. What we have changed is our top line revenue, which you will also see in our integrated financial statements, or more specifically in the cash flow statement. So right now we only have revenue from our capacity tolling agreement, but we haven't run our macro yet. So let's go back to the operations sheet, hit our master macro, and now you can see that we have a new repayment profile in 564, and our DSCR is at a flat 1.3, except in the last period where we have more CFETs and could technically sculpt even more debt. But the reason we are not utilizing that debt that we could size additionally is our maximum gearing ratio or leverage ratio restricting our debt at 137.349. And our actual sculpting would allow 139.379. That's why the DSCR in the last period is slightly higher. Now, if you were to change the input in our inputs time independent sheet under the senior debt section and increase that maximum leverage to 90%, just to see what would happen to our DSCR, we could hit our master macro again. And that would actually lead to a flat 1.3 DSCR for the full tenor. Because now we are not restricted by our gearing ratio or leverage ratio anymore. That would allow for debt of 154 million, which means now the actual sculpting is the restricting factor. But let's make sure that our inputs are in line with our case study. So let's type 80% again. Go back to the operation sheet, hit the master macro, and you will see our 1.3 flat DSCR up to 2039, and then the last repayment in 2040 has even more buffer. Alright guys, this is it for this lesson, and in the next lesson we will build the cash sweep logic, which is where the modeler starts to show real lender behavior. Basically, we will use excess cash to repay debt faster, which is especially important for lenders running sensitivities on mini-perm structures. Alright guys, I will see you in the next lesson. See you there.